Hi everyone, welcome back to the Nim game. Let me remind you where we left off last time. We were discussing this particular situation where it was Akriti's turn and there were 4 coins left in the game. And we saw that this was a bit of a checkmate for Akriti. No matter how many coins she takes out now, because she can only take out at most 3, Alessandra will take out the remaining and win the game. Okay, so if Alessandra is asking herself, okay, how can I ensure a win for myself in this game? It looks like that's the same as asking, how can I ensure that I always have a way of leaving Akriti with 4 coins at the start of Akriti's turn? Here's an observation. Suppose Alessandra can leave Akriti with 8 coins at the start of Akriti's turn. Then notice that again, because Akriti can only take out at most 3, no matter how many she takes out, suppose she only takes out 2, Alessandra can take out 4 minus that number, which would be 2 as well. Oh, I used the wrong colors. So Akriti takes out 2. Alessandra can take out 4 minus that number, which is 2, leaving Akriti with 4 coins at the start of Akriti's turn, thus putting Akriti in a checkmate situation. Okay, so it looks like leaving Akriti with 8 coins at the start of Akriti's turn is also a checkmate for Akriti, assuming that Alessandra plays her moves correctly. Okay. So, how can Alessandra leave Akriti with 8 coins at the start of Akriti's turn? Well, you must have guessed it. If she can leave Akriti with 12 coins at the start of Akriti's turn, then she can also leave her with 8 coins at the start of her turn. By the same reasoning, no matter how many Akriti takes out, say she takes out 3, she can't take out any more. So Alessandra will take out 4 minus that number, which is 1, thus leaving Akriti with 8 coins at the start of her turn. Okay, so it looks like leaving Akriti with a multiple of 4 coins at the start of Akriti's turn is a winning strategy for Alessandra. It's something that guarantees a win for Alessandra. Looks like there's something special going on about this sequence 4, 8, 12, etc. Also, keep in mind that 4 is one more than the maximum number of coins that a player is allowed to take out, namely 3. Okay, let's backtrack even further to the very start of the game. Now, we have 15 coins. Alessandra plays first. We saw that she should leave Akriti with multiple of 4 number of coins. So there's a very clear thing that she should do at the beginning. To ensure a win, she should take out 3 coins. And now it's Akriti's turn. There are 12 coins in the game, and Alessandra is going to win, provided she makes sure that at the end of each play, 4 coins leave the game. Okay. So here's a question. Can the first player always ensure a win? It looks like Alessandra had an advantage here, right? Because she played first, she could make sure that at the end of each turn, Akriti is left with some multiple of 4 number of coins at the start of Akriti's turn. Well, the answer is not so simple. Let's look at a modification of the game. Suppose now we started with 16 coins instead of 15 coins. Notice that 16 is a multiple of 4, and Alessandra continues to play first. Now, because the maximum number of coins that can be taken out each time is 3, there is no way for Alessandra to remove coins in such a way that Akriti is left with a multiple of 4 at the start of Akriti's turn. So suppose Alessandra takes out 3. Now Akriti can actually do what Alessandra was doing earlier, take out 4 minus 3, 1 coin, and leave Alessandra with a multiple of 4 coins at the start of Alessandra's turn. And this means that we see in this case, Akriti is actually the one with the winning strategy. Okay, so who has a winning strategy depends on the numbers that we start with. Let n be the number of coins that we start with in the game, and let k be the max number of coins that a player can remove each turn. We looked at two cases. Case 1, n was 15, k was 3. 15 was not a multiple of 4. Then the first player, the player who plays first, has a winning strategy. And in the other case, n was 16, which is a multiple of 4, and player 2 has a winning strategy in this case. Well, there is nothing special about these numbers. We can say, therefore, in general, that the winning strategy is leaving your opponent with a multiple of k plus 1 number of coins. And which player has the winning strategy again depends on n and k. So if n is not a multiple of k plus 1, then player 1 has the winning strategy. And if n is a multiple of k plus 1, then player 2 has a winning strategy. The winning strategy is the same in each case. It is leaving your opponent with a multiple of k plus 1 number of coins. The idea is that when n is not a multiple of k plus 1, then the player who plays first can take out a certain number of coins and actually make it happen that the other player has some multiple of k plus 1 coins left at the start of their turn. But when n is a multiple of k plus 1, because of this constraint of the maximum number of coins that one is allowed to take out being k, the first player has no way of playing this winning strategy. Therefore, it's the second player who ends up having the winning strategy. Okay, so that was a lot. Try out different n's and k's to really get a hang of and to understand what's going on with this game. It's the best way to work through a mathematical problem like this one is to work through different examples and try out very large n's as well, for instance 100. Because with such large numbers, you won't be able to rely on drawings or props to be able to guide your reasoning. You will have to reason in the abstract, and that's a great exercise. It's something that you can try with your students as well. Okay, so the last thing I want to say is, where is the math in this? Your students might ask you, well, this is Math CEO and we just played a bunch of games, and what math concept does this relate to? And one way for you to conclude the session would be to maybe talk about that. You don't have to go into complicated words or details, but maybe just give them some keywords that they can use to remember what is the math concept that they learned through Wednesday's activity. Some keywords in this case are, you can talk about how game theory is a whole branch of mathematics devoted to the study of different games. And these games, I mean, it's not just for entertainment, although that's a great reason to study something, but we encounter many different situations in life, for instance, bargaining or any kind of like political negotiation. These are different situations in which can be modeled through games, and that's what game theory is about, and that's a situation in which it's applicable. Okay, and you can also talk about how strategic logical reasoning are an important part of mathematics in general, game theory in particular. And you can talk about this technical term of winning strategy that we've been using. We didn't really define it, but it has a definition, namely a type of move that results in a win in every situation. And every is really the key word here, because if there is even one situation in which playing a move does not result in a win, then that move cannot be called a winning strategy. So this is a great way for you to also test out different moves and whether they might be winning strategies or not. You could try to cook up situations in which that move might not result in a win, and then it's not a winning strategy. Okay, so I'll leave you with this, and I hope you have a lot of fun with this activity, and good luck.